Good afternoon, class. So you guys had homework. It was on exercise 1.9 on page 18, the first column. Is that correct? Okay. Out of exercise 1.9, first column, was there any issues from numbers 1 to 5? Any issues from numbers 1 to 5? No. Was it from number 7 to 23? Any issues there? The odd numbers? Yes? What? 23. Any other issues? It's a very important exercise for your grade 12 syllabus. So I would like you guys to do the second column for homework out of this exercise 1.9, the second column. Did I give you that already? Sorry? Yes, I gave you the whole exercise. Okay. So I said I was going to do these odd numbers today, no? Okay. And then I can do number 23 as well. Alright. So let's go number 7. Number 7, you're going to get the root of 2. 18 can be written as 2 times 9. 8 can be written as 4 times 2 minus 49 times 2. That will be the square root of 2 into. This will be square root of 9, square root of 2 plus square root of 4, square root of 2 minus square root of 49, square root 2. It will be the square root of 2 into, the square root of 9 is 3. Root 2 plus 2 root 2 minus 7 root 2. As you can see, it's like terms inside the bracket. So 3 root 2 plus 2 root 2 is 5 root 2. 5 root 2 minus 7 root 2 is negative 2 root 2. Negative times positive is negative. Root 2 times 2 root 2 is 2 times root 4, which is 2, which is negative 4 as your answer. Alright. Any issues there? No? Because of space here, I'm going to delete as I'm going along. That was number 9. So the next one is, of course, number, no, it was 7. Yes, 9. What you should notice here, it's a conjugate pair. 1 plus 1 minus. They're exactly the same. Provide 1 plus 1 minus. So we can multiply the first and the last. 4 times 4 is 16. Positive times negative is negative. 3 times 3 is 9. Root 2 times root 2 is 2. So it's 16 minus 18, which is negative. Look at number 11. Again, conjugate pair. You multiply the first and the last. This will result in the difference of 2 squares. No? You guys are familiar with this. Root 8 times root 8 is 8. Root 7 times root 7 is going to be 7. This gives you an answer. You all okay with that? That was number 11. So 13, 15. Again in 13, the conjugate pair. You can multiply the first and the last. 5 times 5 is 25. Negative 2 times positive 2 is negative 4. Root 3 times root 3 is 3. So it's going to be 25. What's 4 times 3? 12, which is 13. The next one, the root of 27 can be written as the root of 9 times 3. 48 is going to be 16 times 2, is that correct? No. 3. 16 times 3 plus 25 times 3. You all agree with that? So that's going to be root 9 times root 3, root 16 times root 3, plus root 25 times root 3. So root 9 is going to be 3 root 3. The root of 16 is 4 root 3. Root 25 is 5 root 3. We add the like terms there. So root 4 root 3 plus 5 root 3 is going to be 9 root 3. 3 times 3 is 3 times 9, sorry, is 27. Root 3 times root 3 is 3. Or root 9. 27 times 3 is 81. Any problems there? Now you see, when we mark this, this is what we want to see. Okay? The sum normally reads without the use of a calculator, evaluate or calculate or simplify, whatever. Okay? Alright. Number 17. And that's going to be 4 root 18 can be written as 9 times 2 minus 3. 8 can be written as 4 times 2. And this is all over the root of 25 times 2. Which is 4 root 9 times root 2 minus 3 root 4 root 2. All over. Root 25 root 2. So the root of 9 is 3. 9 times 3 times 4 is 12. So it's 12 root 2 minus. The root of 4 is 2. 2 times this 3 is 6 root 2. Over the root of 25 is 5 root 2. So 12 root 2 minus 6 root 2 is 6 root 2 over 5 root 2. The root 2 is cancelled, so it's going to be 6 over 5. You guys okay with that? Any confusion? No? The last one is on the board. I think the others is further down. So 50, I can do one of two things. I can either use the binomial square at this point, or I can simplify. I'm going to go and simplify. Well, I'll do it both ways for you. Okay, so it's going to be 25 times 2 minus the root of 16 times 2. Okay? So that would be the square root of 25 root 2 minus square root of 16 root 2. Square root of 25, 5 root 2 minus 4 root 2 squared. That will give you root 2 squared, which is 2. Alright. Number 21. Again, is that the conjugate pair? Oh yes, I said I was going to do the other way as well. We would have taken the first, the binomial square. So its first term squared is root 50 squared is 50. That times 2. It's going to give you negative 2 root 50, root 32, plus the last term squared, which is 32. Now 32 plus 50 is going to be 82 minus. Okay? Now root 50 times root 32, you can multiply that out. Okay? It's going to give you 50 or 1600, which is the root of that's going to give you 40. 40 times 2 is 80, and 82 minus 80 is again 2. Okay? Now let's play dumb, and we didn't know that. Okay? So root of 50 can be written as 25 times 2. Root 32 is going to be 16 times 2. Okay, so it's 82 minus. Now it's 2 root 25 root 2. Root 16 root 2. So it's 82 minus. That's going to be 2 times 5. Now root 2 times root 2 is 2. 16 is going to give you 4. So it's 82, that's 10, 20, 80. Which is 2. Okay. 2 as well. So either way, as long as you're doing it mathematically correct, not bridging any mathematical rules, you should get the same answer. People again conjugate pair. Multiply the first and the last. You see, there's so much I can ask you. You see, there are many questions are repeated questions. And why is this exercise so comprehensive? because that's important for your grade 12 syllabus. Okay? Root 30 times root 30 is going to be 30. So negative times positive, negative. 3 times 3 is 9. Root 2 times root 2 is 2. So it's 30 minus 18, which is 12. The last one, and that's the one that was indicated to be the problem. What I'll do first is I'll simplify. There's actually a what's the name, squared, a binomial squared. Okay, if you want, you're going to multiply the whole story up. Okay, but it's going to be a very messy business. So the root of 72 can be written as 36 times 2 minus 18, which is the root of 9 times 2 plus the root of 5. You all agree the brackets are exactly the same. So it can be written as squared. So that is going to be the root of 36 root 2 minus root 9 root 2 plus root 5. So that's going to give you 6 root 2 minus the root of 9 is 3 root 2 plus root 5 squared. Those are like terms, so that's going to give you 3 root 2 plus root 5 squared. So let's square the first term. 3 root 2 all squared is going to be 9. Root 2 times root 2 is 2. That times 2 will be positive 6 root 2 times root 5, which is going to be 10. No? Last term squared is going to be root of 5 squared, which is 5. What's 9 times 2? 18. 18 plus 5? 23. Right, so where did you go wrong in the sum, Michael? Yes? Six root 10. But you understand? Okay, anybody else? Okay, so then you have to do the even numbers. Okay. Any issues with the even numbers? Huh? Any issues with the even numbers, people? No. That now brings us to rationalizing the denominator. That's on page 19. Okay, rationalizing the denominator on page 90. We are told that it is usually more accurate and more convenient to work with expressions where the numerator and not the denominator is an irrational number. Okay, hence the heading, rationalizing the denominator. So when is something irrational? Or examples of irrational numbers are surds, not so. So to get rid of the surd, okay, or the surd in the denominator, is a small process that we will be doing, okay. To convert an expression to form such to such a form, we rationalize the denominator. So remember, what's the square root of 2 times the square root of 2? 2. What's the square root of 2 over the square root of 2? 1. What's the square root of 5 over the square root of 5? 1. What's the square root of 5 multiplied by the square root of 5? 5. You all okay with that? Okay. So now let's look at these examples on page 19. The question says, write the following with rational denominators. Okay. Write the following with rational denominators. So 1 over square root of 2. Is that denominator rational or irrational? Irrational. Why? Because it's a surd in the denominator. So to get that rational, I multiply this by a number 1. If I multiply that by a number 1, would I be changing anything? Would I be changing anything? No. Remember in mathematics, we don't change the value of anything. We only simplify. Okay? But the number 1 we choose strategically in such a way that we can change the denominator from irrational to rational. So 2 multiplied by what will give me a rational number? Root 2 multiplied by root 2. So what goes on top? Root 2. Why? So root 2 over root 2 is 1. Oh yes, you guys understand? So what is root 2 multiplied by root 2? Root 4, which is 2. What is 1 times root 2? Root 2. That means to say 1 over root 2 is equal to root 2 over 2. Understand? Now you try, let's do the next one together. Let's do the next one together. Write the sum down. Okay? So what must this number be multiplied by? The denominator, which is root 7, is it rational or irrational? Irrational. So root 7 must be multiplied by what to give us a rational number? Root 7, exactly the same thing. Not so? So what must go into the numerator? Why root 7? Because that will form a 1 there. Root 7 over root 7 was 1. You guys understand? So what is 14 times root 7? 14 times root 7. 14 root 7, yes. What's root 7 times root 7? 7. But what do you notice now? 7 can cancel it. 7 going to 7 once, 7 going to 14. Twice. There's going to be 2 root 7 over 1, which is 2 root 7. You guys understand? Right. Try number 3 quickly. Quick. Are you guys finished? Sorry? No. Okay. Should be done now, no? Right. So what are we going to multiply this number by? Root 5 over root 5. So what's 5 times root 5? 5 root 5. What's root 5 times root 5? 5. So what can happen now? What can cancel? The 5s. So we are left with root 5 over 1, which is square root 5. You will understand. It's easy, no? So far. Everything in maths is easy, man. The instruction is write the following with rational denominators. It's now page 19. Guys ready? Yes, okay. So, what is different with number 4 and 5 opposed to what we have dealt with before? There's two numbers now. Not so? Or there's two numbers. Let's call it two numbers for now. So how do you think we're going to rationalize the denominator in this case? Was multiplied by, yes? 2 plus root 3. You all agree with that? Yes, let's see what happens. So you multiply this by 2 plus root 3 over 2 plus root 3. The numerator is going to be 5 into 2 plus root 3 over, we multiply 2 by 2, I get 4, 2 by root 3, I get 2 root 3, 2 by root 3, I get 2 root 3, root 3 by root 3, I get root 9, which is 3. It's going to give me now 5, I can normally keep that to last, 2 plus root 3 over 7 plus 4 root 3. Have I sorted out the issue? No. I haven't rationalized the denominator there. So that is not right. Yes, 2 minus root 3. Let's see what happens. Let us see. Why do you think that you needed to have done that? Because yes, good start. Yes, you could. Alright, so we can multiply the first and the last. So that's going to give you 4 minus root 3 times root 3. 3. 5 into 2 minus 2. You see the issue is now sorted in the denominator. So 4 minus 3 is? 4 minus 3. Yes. And we can multiply that out there. So it's going to give you 10 minus 5 root 3 over 1, which is exactly that. You understand? Try number 5 quickly. I'll pause the video. Try number 5. Okay, so at this point you should have been done with the even and odd numbers. Okay. So the answer to number 1, 3 over root 3. What we're going to do, we're going to multiply this by the root 3 over the root 3. Not so? So it's going to give you 3 root 3 over 3, which is root 3. Any confusion there? No. Number 5. Sorry, number 3. So it's 1 over root 7 must be multiplied by root 7 over root 7. So it's going to be root 7 over 7. You all agree with that? Number 5. It will be 3 plus root 2 over root 2. What must this be multiplied by? Root 2, yes. Because I will be looking at the denominator. So root 2 times root 2 is 2. Root 2 times 3 is 3 root 2. Plus root 2 times root 2 is 2. No common factor. You all okay with that? Okay, let's look at number 7. Got 60 over 5 root 12. What are we going to multiply this by? Root 12 over root 12. Not so. So that would simply give us 60 root 12 over root 12 times root 12 is 12 times 5 is 60. No, 12 times 5. Yeah, 12 times 5 is 60. Not so? So 60 goes into 61, 60 goes into 61. So I'm left with the root 12, which is also 4 times 3, which is 2 root 3. Okay? Or I could have reduced that. Okay? As 60 over 5, 12 can be written as 4 times 3. 4 times 3 is, root of 4 is 2. 2 times 5 is 10. So it's 6 over 10 root 3, 60. 10 going 10 once, 10 going 6 times. So I multiply 6 root 3 by root 3 over root 3. I think that's a bit longer, no? So that's going to give you 6 root 3 over root 3 times root 3 is 3. 3 going to 3 once, 3 going to 6 twice. So it's 2 root 3. As you can see, there's more than one way of doing things. Okay? Sometimes it will be easier your way than even my way, or another way. Okay? You all okay with that? It's number 7. Number 9. So it's 6 over root 10 minus 3. Yes? Yeah? But of course that's not in the simplest third form. Then you must be prepared to lose 1 more. But you want okay, you can lose that 1 more, doesn't matter. Or you want all your marks. You like all your marks. Then you must do all the work. No, you don't. Right, so this must be multiplied by what? Root 10 plus 3. Not so. So what do we do? Multiply the first and the last. So root 10 times root 10 is 10. The negative 3 times positive 3 is negative 9. So that's going to give you 6 into root 10 plus 3. So 10 minus 9 is 1. So I can just multiply this out here. So that's going to give you 6 root 10 plus 18. Number 11. 24 over root 10 minus 2. What must this be multiplied by? Root 10 plus 2, root 10 plus 2. It will be nice if you guys talk to me. Right, which is what? First times the last. It's going to give you 10 minus 4. So it's going to be 24 into root 10 plus 2. Now do you see, what is 10 minus 4? 6. 6 goes into 6 once, 6 goes into 24. 4 times. Can you see the benefit of keeping it like that? Okay, which is now going to give us 4 times root 10 is 4 root 10. 4 times 2 is 8. Okay, any confusion at this point? No? Uh, 13, we just did, so 15 is the last one. No, we didn't do 30. No. So it's going to be 30 over root 10 plus 2. So this must be multiplied by root 10 minus 2. Okay. Multiply the first and the last. So that's going to give you root 10 times root 10 is 10 minus 4, which is 6. Not so? So 6 goes into 6 once, 6 goes into 30, 5 times. You see that, people? Hello? Yes. People will think I'm crazy. So talk to me. 5 times root 10, 5 root 10 minus. Alright, and the last one, number 15, is 12 over 2 root 5 plus 4. So what would its conjugate pair be? 2 root 5 minus 4 over 2 root 5 minus 4. Okay. Can you multiply the first and the last? So 2 root 5 times 2 root 5 is 4 times 5. Root 5 times root 5 is 5, or root 25. Negative 4 times 4 is negative 16. So it will be 12 into 2 root 5 minus 4. What is 4 times 5? 20. 20 minus 16? 4. 4 goes into 4 once, 4 goes into 12? 3 times. So we multiply this now. So that will be 3 times 2 root 5 is going to be 6 root 5 minus 3 times 4 is 4. Okay. All okay with that? Homework is all the even numbers. Okay. Now we're looking at equations involving surds. Equations involving surds, and this is on page 20. Equations involving surds. By definition, the root of x is positive. By definition, the root of x is positive or 0. Okay, not so. The square root of any number is either positive or it's 0. Not so. Choose any value. Choose a value. 4, yes, nice. What's the square root of 4? 2. Choose any other number. 5. Square root of 5 is going to lie between 2 and 3. So it's 2 comma something. Put in your calculator. Square root of 5. Two comma 2, 3 and so on. But this is a positive number, not so. Choose any other value.
7.
Okay, another value? 13. You say it will always be positive. I'm expecting somebody to say minus 4. Nice, nice. So the square root of minus 4. What do you think that would be? Undefined, non-real. Okay. So that is the answer to a square root. If it's real, it will always be 0 or positive. Does it make sense? We therefore need to keep this in mind when solving the equations involving surds. Alright. Solve these sums quickly. I'm going to just pause the video quickly. Alright. So at this point should be done. So the first one. Which page is this on? Sorry? 20. Okay. So, the first one. Now we're going to solve the first one. We're going to cube both sides, not so. So the cube and cube root cancel, so x squared is equal to 9 cubed. Is 729, I think. Is that correct?
Yes, sir.
Yes. Now what do? Do I introduce a square root? What must I not forget? Plus minus. So x is equal to plus minus 27. Right, you all got that right. Yes, Michael, your hand is up? Yes? Both of your hands is up. Anyone? Yes? Yes? Yes, that could also be done. Let's do it that way. So it's going to be x 2 over 3 equals 9. So we're going to raise this to its reciprocal, which is 3 over 2. But what's the rule if the numerator is even? You must not forget plus minus. Did you forget plus minus, Michael? That's the problem. So x is equal to plus minus 3. 9 can be written as 3 squared raised to the 3 over 2. So it's going to be plus minus 3. 2 is cancelled, 3. Which is plus minus 27. Okay. Let's look at number 2. Number 2. We got the square root of x cubed equals 64. Right, what must happen here? What needs to happen here? We're going to square both sides. Not so. So 64 is 2 to the 6, I think. No? So x cubed is equal to 2 to the 6 raised to the power 2, which is also equal to 2 to the 12. Now what do? How do we get x on its own? We take the cube root both sides. So x is equal to 2 to the 12 divided by 3 is 4. And 2 to the 4 is 16. Do you guys get that one right? Right? Any issues regarding this one here? Yes, my girl?
What if you didn't say that you used about 6 to about 12, this is the actual number?
So you got 64 squared without using a calculator. No. Is how much?
No, but like, what if we gave it like, do you have to put it to
You don't really have, no.
So,
What you could have done at this point also, I could have said x cubed equals 64 squared, isn't it? The cube root of 64. What's the cube root of 64? 4. You see, I took that first, and 4 squared is 16. So it's also that. Could have done that as well. No problem. You can use the numbers also, yes. Remember in maths, we just want to give you answer the marks, but you guys don't want the marks. No? Okay, any other confusion? Right, let's look at number 3. Look at number 3. You got the square root of x minus 3 is equal to 2. So what do I do here? I'm going to square both sides, not so. That cancels. So I'm left with x minus 3 is equal to 2 squared, which is 4. Now what? Over. So x is equal to 7. And we can check. When you get it in this form, you always check. The square root of, for the left hand side, 7 minus 3. This is the left hand side. Yeah? What is 7 minus 3? 4. What's the square root of 4? 2. Is the left hand side equal to the right hand side? Yes. So 7 is good. Let's look at number 4, which at this point you have also completed. So you got the square root of x plus 4 equals negative 2. Can this be solved? Yes. Okay, let's see. Actually we can't, but okay, let's act like we don't know. Let's say we act dumb and we don't know. You're not dumb, no? You didn't say you're dumb. Alright. So we say, okay. So how are we going to solve the sum? We're going to square both sides. For those of you who are saying it can simplify. So it becomes x plus 4 equals 4. Take it over. So x is equal to 0. And test if it works. You put 0 into the left hand side. So you're going to be square root of 0 plus 4. This is the square root of 4, which is 2. Is 2 the same as negative 2? No, so no solution. But we should have seen that the square root from a negative number is not going to work. So immediately, when you got the square root of x plus 4 equals negative 2, you can write there, no solution. Pull a line and write no solution. Right, you guys understand?
yes.
Any confusion? Right. For homework, I want you guys to do exercise 1.11. The first column. 1.11, the first column, and this is on page 21. Okay. People enjoy the rest of your day. Good afternoon, class.